7.1 is on the topic of integration by parts. Integration by parts is a method that we use when we're trying to take the integral of a product of two functions. I'm going to actually start with product rule to look at the formula for integration by parts. The product rule says if we take the derivative of f times g, we would get f times derivative of g plus g times the derivative of f. So that's our product rule. I'm going to manipulate this formula a little bit. First, I want to switch sides. So I'm going to move the right side over to the left and move the left side over to the right. The next thing I want to do is take the integral of both sides. I'm going to take the integral of both sides with respect to x. On the left, I'm going to write each of the products individually. So I'll write the integral of f g prime, and then I'll write plus the integral of g f prime, and that equals f times g, because on the right side I took the integral with respect to x of the derivative with respect to x of f times g. So the integral and the derivative undo each other. Now I'm going to subtract the second term over to the right. So we get the integral of f times g prime equals f times g minus the integral of g f prime. This is our formula for integration by parts. We will be given an integral of a product. Notice how we will consider one of them to be a function and the other to be the derivative of a function. When we go to set up our formula, we're going to use f and g, so you'll have to find the antiderivative of g, and then we need the derivative of f, so you'll take the derivative of f. There's a shorthand to this. I'm going to let u equal f of x, and I'm going to let v equal g of x. This is very common in all the textbooks. The integral of u dv equals u times v minus the integral of v du. So I'll repeat that a lot. I'll say u times v minus the integral of v du. Every time you do a problem using integration by parts, you're going to have to choose which function is the u and which function is the dv. We'll start with this example. In the example, the integral of x cosine x, I'm going to let u equal x, and I'm going to let cosine x equal dv. And I suggest this setup format. I'm going to make a small chart where I let u equal x, and I let dv equal cosine x dx. Right? That's a derivative, so it would have a dx there. Then you're going to take the derivative of u, so that's du equals dx, and you're going to take the antiderivative of dv. So we get v equals the antiderivative of cosine is sine. Now you have the pieces to set up the formula. Our math problem was the integral of x cosine x dx. That will equal u times v. Now u is x and v is sine x. So u times v is x times sine x. And then we're going to do minus the integral of v du. So write the integral symbol and you're going to put v times du. Look at your chart. V is sine x, du is just dx. So the integral of sine x dx. Now, to finish this math problem, I'm going to work out this integral. This is a much more simplified integral than what we started with. What we started with was the product of two functions. Now we just have the integral of one function. And I'm going to find the antiderivative of sine, which is negative cosine. So the antiderivative of sine is negative cosine. And this is an indefinite integral, so you need plus c. The answer is x sine x plus cosine x plus c. If you want to check your answer to see if you are correct, you could take the derivative of your answer and see if you get x cosine x. So that would be taking the derivative with respect, okay, I'll write to check this. To check your answer. You don't have to do this, but this is how you would do it. Take the derivative with respect to x of x sine x plus cosine x plus c. Product rule on x sine x. So first times the derivative of the second plus second times derivative of the first. The derivative of cosine is negative sine, and the derivative of c is 0. So we get x cosine x. The sine plus negative sine add up to 0. So I just checked it. I can tell that my answer is correct. Now in the second example, I have two functions being multiplied together. 2x plus 1 is a linear function, and e to the negative x is just a transcendental. And it's pretty easy to find the antiderivative of e to the negative x. So I'm going to do this. When the other function, the e to the negative x, is easy and you can find the antiderivative of it, then my rule is always let the polynomial equal u. For my setup, make my table, I'm going to let u equal 2x plus 1. That means dv is going to be e to the negative x dx. All you have to do is take the derivative of u on the left, so du equals 2 dx. And then on the right, the antiderivative of e to the negative x is negative e to the negative x. And now I can use my formula. Remember, the integral of u dv is u times v minus the integral of v du. So that's our formula. Setting up our work, the integral of 2x plus 1 times e to the negative x is u times v. So that is 2x plus 1, that's u. V is negative e to the negative x. So I'm going to put the negative out in front, e to the negative x, minus the integral of v du. So v is negative e to the negative x, and du is 2 dx. So I'm going to have negative 2 e to the negative x dx behind the integral symbol. So this is negative 2x plus 1 e to the negative x, and it's going to be plus 2 times the integral of e to the negative x dx. And notice how I pulled out the negative 2, and I can just easily look at e to the negative x in order to find the antiderivative. So I'm rewriting the first term, and the antiderivative of e to the negative x is negative e to the negative x. So it'll be minus 2 e to the negative x plus c. The next example, it doesn't look like it's the product of two functions. The natural log of x seems to be the only function here, but this one is special, so we're going to set this one up. Let u equal the natural log of x. Let dv equal dx. Take the derivative of u, take the antiderivative, v equals x. Set up our formula. Remember, our formula is the integral of u dv equals u times v minus the integral of v du. So the integral of natural log x dx is u times v, so that would be x natural log x, minus the integral of v du. V is x, du is 1 over x dx. So I'm going to write x times 1 over x dx, and you'll see that the x's will cancel. So it's really the integral of dx, and the integral of dx is just x. We get x times natural log x minus x plus c. So you can choose to do this every time, or you can try to remember that the antiderivative of natural log x is x natural log x minus x. The next example. This example has a polynomial times a trig function. I'm going to choose to let u be that polynomial. So u will be t squared, and dv is the sine of 2t dt. Take the derivative on the left, take the antiderivative on the right. Now this is an angle of 2t, so I have to do a correction factor of 1/2. And remember, the antiderivative of sine is negative cosine, so it'll be negative 1/2 cosine of 2t. If you need to use a u substitution to deal with that angle of 2t. Now I'm going to set up my formula. Remember, the formula is the integral of u dv equals u times v minus the integral of v du. The integral t squared sine of 2t dt equals u times v will be negative 1/2 t squared cosine 2t minus the integral of v du. So v is negative 1/2 cosine, and du is 2t dt. I'm going to write them both in here. 1/2 cosine 2t times 2t dt. That way you'll have a moment to see. The 1/2 times the 2 will be 1. And then I have minus the integral, and the integral is negative inside, so they'll change it to plus. So I'm going to copy this front part down, and then minus the integral of the negative, so it's going to be plus. 1/2 times 2 is 1, so I'll just have a t in the front of the integrand, and then a cosine of 2t dt. So this 2 canceled with that 2. Okay, we have a problem. The result gave us an integral that has a product in it. So I'm going to have to do it again. -1/2 t squared cosine 2t is fine. For that integral, I'll set up my chart. U is going to be the t. dv will be cosine 2t dt. The derivative of u is dt. The antiderivative is a correction factor of 1/2. The antiderivative of cosine is sine. Okay, let's set that up. So we will get u times v. So that will be 1/2 t sine of 2t minus the integral of v du. So v is 1/2 sine 2t and du is dt. So we can take the antiderivative of that. Gosh, I wish there was an easier way to deal with that. Well, I'm here to tell you there is. When you set this up in the first place, go back up to the top. Up at the top, we let u equal t squared. So when you go to take the derivative, you'll be left with t to the first. And that's the reason why we had to do this again. Look at that, t to the first ended up right there in the middle of our work. When you have integration by parts and your u is going to be a polynomial of second degree or greater, you can consider doing something called tabular integration. So tabular integration means you're creating a table and there's rules about the table. So these are the rules. You're going to set up u in the first column and you're going to set up dv in the second column. Your original u was t squared. Our dv was the sine of 2t dt. But see how I'm putting it in a table like this. And what we're going to do is we're going to fill out the table. So go down the first column, go down the u column, taking the derivative. The derivative of t squared with respect to t is 2t. The derivative of 2t is 2. And the derivative of 2 is 0. Once you get to 0, you can stop. So take the derivative of that polynomial until you get a 0. Then on the right side, you're going to be taking antiderivatives. So the antiderivative of sine 2t is -1/2 cosine 2t. And the antiderivative of that is -1/4 sine 2t. You know the sine and cosine are just going to toggle back and forth. +1/8 cosine of 2t. In the formula for integration by parts, I'm going to scroll up a little bit here. In the formula for integration by parts, there is a minus sign before the integral. So because of that minus sign, I have to think about a minus sign in my table here. What you need to think about is there's going to be a negative every other term. What we do is we put a negative on every other term in the left column. Make 2t a -2t, and then you would make this negative, although you don't really need to because it's 0, but that's the rule. So you're going to make every other term negative. And what I mean by term is this. The answer to the math problem is when you multiply this first t squared by this second in the dv column, and then you multiply this by this in the second column, and then you multiply this by this, and that's your answer. So look at this. I'm going to multiply the first two together, so I'll get -1/2 t squared cosine of 2t. Isn't that the first term we got when we did it the long way? And then it's going to be minus 2t times -1/4. So negative times negative is going to be +1/2 t sine of 2t. And then the next one is going to be plus 2 times an eighth is a fourth cosine of 2t. And don't forget your plus c when this is an indefinite integral. Do you like it? Do you like tabular integration? I hope so. Let's use tabular integration to do the next example. Please pause the video, do the next example, and then turn the video back on to check and see if we got the same answer. I'm noticing there's a polynomial in there, and this guy is easy. I could just keep taking the antiderivative of e over and over again. So this is a candidate for tabular integration. I know I told you to do that, but you could figure that out on your own also. There's a u column and there's a dv column. You let u equal t to the third, and you take the derivative of that going down. dv column starts with e to the negative 2t, and you don't have to put the dt there because you're going to be taking the antiderivative here. The antiderivative of e to the negative 2t is negative 1/2 e to the negative 2t. Now remember to put in the negative sign on every other term. So make 3t squared negative. Make 6 negative. So don't forget that. And now to set up your answer, you're going to multiply the first term in the first column against the second term in the second column. So you will get negative 1/2 t cubed e to the negative 2t. Then I'm going to multiply these two together. So it'll be negative 3/4 t squared e to the negative 2t. And then I'll have negative 3/4 t e to the negative 2t, and then negative 3/8 e to the negative 2t. Don't forget plus c. Okay, I want to show you a cool one. I have two transcendental functions here, so there's no polynomials here. I'm going to go back to our original method where I let u equal something and I let dv equal something, and maybe I'll pick e to the x as my u, and I'll pick cosine x dx for dv. So take the derivative and then take the antiderivative. So that means the integral of e to the x cosine x equals u times v is e to the x sine x minus the integral of v du, which is e to the x sine x. I forgot that. Don't tell anyone. Uh-oh. Look at what we have here. It's repeating. Now put brackets here because there's a minus, so that's kind of dangerous. So if I set up a little table again and do that same thing, negative e to the x cosine x minus the integral of v du. So that will be negative e to the x cosine x dx. Zip. Let me distribute that negative sign plus a positive when I do this, and then I'm going to switch this to a positive. So I'll get a negative here. Our original problem was integral e to the x cosine x. Well, we have another one, integral e to the x cosine x, right over here. Watch this magic. I'm going to add this integral to both sides, because otherwise I'll just keep repeating myself over and over and over again. So on the left, there are two of them, 2 integral of e to the x cosine x. And on the right, I have e to the x sine x plus e to the x cosine x. And I'm trying to solve for that integral. So I just need to go and divide both sides by 2 or multiply both sides by 1/2. So I'll get the integral of e to the x cosine x dx actually equals half of e to the x sine x plus e to the x cosine x. You can't forget the plus c. You could also factor out that e to the x. Number 30 is a definite integral this time, so we're not going to put plus c. We're going to evaluate it in the end. Please pause the video and work out number 30, and then turn the video back on to check your answer. Setting up the table to begin with, I will pick natural log of w as u instead of the polynomial. I can easily take the derivative of natural log. You may have memorized the antiderivative of natural log by now because we did it earlier in the lesson. You could have done it that way also. W squared dw will be my dv. Take a derivative. And let's try number 32. It is a definite integral, so we will evaluate when we're done. But also notice this is a t squared times sine 2t. So let's go with our tabular integration method. Please pause the video, try tabular integration, and finish the problem, and then turn the video back on to check your answer.